The question we are going to discuss today is with reference to oil monitoring of bilge and tanker ballast discharges, describe with the aid of a sketch the general arrangements of an oil monitoring system, state the inputs that are recorded, explain the difficulties encountered with the efficient operation of the oil monitoring system. Let us start with the first part. Describe with the aid of a sketch the general arrangements of an oil monitoring system. In this sketch, from oily water separator discharge line, a sample is taken to the sampler where it analyzes with the photoelectric cell and ultraviolet light the ppm of the oil inside the overboard water that are taken from the bilge tank, and it gives signal to the controller. The controller checks whether it is more than 15 ppm or less than 50 ppm. If it is less than or equal to 15 ppm, it gives the signal to the three-way bulb to discharge it overboard, else it will be diverted to the bilge holding tank. An oil content monitor is a device for real-time sampling and measuring of the oil content in a moving stream of water. It monitors for oily water separators perform several functions including preventing illegal over-limits discharges that occur when the oil content is above 15 ppm by either shutting down the separator or by putting the separator into a recirculation or recycle mode where the oily bilge water is sent back to the oily waste holding tanks. A sample of water leaving the OWS is drawn off automatically and passed through a detector cell. A low power light shines a beam through window in the side of the detector. This is transmitted through the water sample and picked up by a detector on the far side of the cell. Pure water will only have a slight attenuating effect on the beam, whereas oil will absorb the light, reducing the intensity reaching the detector and causing the oil content monitor to sound the alarm. Let's move to the second part of the question. State the inputs that are recorded. As per the regulation, the following inputs must be recorded by the system. Discharge rate of the pump which is discharging the oil-water mixture overboard, the allocation of the ship in latitude and longitude, date and time of the discharge, the total quantity that has been discharged overboard, oil content of the discharge mixture in ppm. All the records of ODMCS, Oil Discharge Monitoring Control System, must be stored on board ship for not less than 3 years. Let's move to the third part of the question. What could be the possible changes to an efficient operation of the oil discharge monitoring system? The possible changes to an efficient operation of the oil discharge monitoring system are calibration issues. Inaccurate calibration of the oil content meter and flow meter can lead to incorrect readings, resulting in non-compliance with regulations and potential environmental damage. Maintenance and inspection. Regular maintenance and inspection of the system are crucial to ensure its accuracy and reliability. Failure to comply with maintenance schedules can lead to system failure and non-compliance with regulations. Human error. Human error can occur during the operation and maintenance of the system, leading to incorrect readings, system failure and non-compliance with regulations. Technical issues. Technical issues such as sensor malfunctions, software glitches, or hardware failures can cause the system to malfunction or provide inaccurate readings. Power outages. Power outages can cause the system to malfunction or shut down, leading to potential environmental damage and non-compliance with regulations. Training and knowledge. Lack of training and knowledge among crew members can lead to incorrect operation and maintenance of the system, resulting in non-compliance with regulations and potential environmental damage. Regulatory compliance. Failure to comply with regulations and standards can result in heavy fines, detention of the ship, or even criminal prosecution. System integration. Integration issues between the oil discharge monitoring system and other shipboard systems can cause technical issues and affect the efficient operation of the system.